So we're now going to talk about one more set of characteristics related to functional interfaces. We've talked about a whole bunch of different functional interfaces. We've talked about predicates and functions and bifunctions and consumers and suppliers and so on. And so now what I'm going to do is wrap up with an overview of a few other things to be aware of when you start working with functional interfaces. So what are some of the properties? Well, it turns out that functional interfaces, in addition to having this one abstract method that we've been talking about, like test or apply, or the other methods that you have, like get and so on for suppliers, and the accept method for consumers and so on. You can also have default methods or you can have static methods defined in functional interfaces. And so if you have a functional interface like the one shown here, you can have default methods. You can see there's a bunch of default methods. So the particular example we're looking at is something called the comparator, which is a function that imposes a total ordering on some collection of objects. We saw an example of this earlier when we were talking about the functional interface and sorting the stooge list of threads. And this annotation, which is spelled incorrectly, it should be functional interface, not functional interface, function la interface. That's the French spelling, I suppose. Basically, it's an annotation that instructs the compiler that this is intended to be a functional interface, and therefore the compiler can do a little bit of sanity checking to make sure you haven't done something amiss with your definition of the functional interface. So here's the abstract method that's important in this particular functional interface. This is the compare method. As you can see, it takes two parameters of type T, so it's strongly typed because it's a generic, and it returns essentially 0 if they're equal, -1 or a negative number if the first one is less than the second one, and a positive number if the first parameter is greater than the second one. There's also a default method called reversed. And as you can see, what happens with reversed is it allows the comparison to take place in reverse order. So ascending comparisons become descending comparisons and vice versa. So that's an example of a default implementation. And if you don't do anything to the contrary, if you don't override that method in some implementation of the comparator interface, it'll go ahead and choose that one. There's also a static method called reverse order. And unlike default methods, which can be overridden by implementations, the reverse order method is static. So it's the one and only definition of this particular implementation. So again, you can use this without requiring an object of the class because that's the way that static methods work. Then the final method I'm going to show you here is a little bit wonky, and you're just going to have to kind of memorize this as a special case. So there's also a method called equals that's being defined here too. And this is used to check to see whether two elements are equal, or this element is equal to the obj parameter. And what's interesting about this particular method is it's also abstract. And so at first glance, you might say, well, hey, this is a violation of the rule that functional interfaces can only have one abstract method. Well, it turns out there's a special case where any methods that are overridden from public Java Lang object don't count as part of the interface's abstract method count. And remember that all interfaces, all objects, all inherit or implement implicitly the java.lang.object class. And there's a method in there called equals. And that method actually is not abstract, but in this particular case, it's been made abstract, so you have to go ahead and implement it. But basically what's happening here is those methods that are defined in java.lang.object are treated specially, and they're not included against the one abstract method in a functional interface rule. And that's a little bit weird, but that's just the way it is in Java. So you just have to remember that those types of methods don't get counted towards the abstract method count. So the actual abstract method here, of course, is the compare method. Okay, so that's just a quick recap, a quick summary of the final issues related to functional interfaces. We will use functional interfaces all over the place in this class because that's the way we're going to use, that's the types that we're going to be passing to various methods in streams, various methods in Java completable futures, various methods in RX Java and Project Reactor. So you'll see a lot of these things again, and it's very helpful to understand the principles that underlie the concept of a functional interface.